Hello, everyone, and welcome. Let's talk about today's time forecasting and time series lecture, and first lecture, and go to the forecast and time series analysis lecture, and you can download all the Jupyter notebook and data file we're going to use for this lecture. And today we're going to start talking about the first notebook called forecasting_1, and you can download that. I already downloaded for on my computer and pulled it up. So we're going to start talking about today's using this notebook. This notebook contains the Panda data frame exercise, but using for your forecasting application you learn from production planning and inventory control. So here we also give you a textbook as a reference, and if you're interested in any of the theoretical background for these techniques we're going to talk about. First, we're going to load the data. Okay, import pandas, matplotlib, which is for visualization, and import NumPy library first. And secondly, we're going to define some data set we're going to use for as an exercise at the beginning. So we have first is the oil data from 1996 to 2008. Okay, and second we have this air quality data from 1990 to 2005, and these data are frequency. A stands for the frequency is annual basis, so once a year. One data represents the yearly data. Similar. Livestock 2 and 3, these are the livestock commodity prices. One from 1970 to 2001, and also frequency equal annually. The other one is from 2001 and 2000 to 2008. We only have A data. This frequency also annually, which is yearly. Last one is the Australia retail index, and these are data from 2005 to 2010, but quarter four and the fourth quarter, and frequency is quarters basis. So showing you a variety of data, how you describe their indexes, what type of frequency. Since we're dealing with time series, many times we need to define what kind of data frequency we have in these data set. All right. So let's execute these. And first, we're going to exercise the simple exponential smoothing, and we're going to plot the data for oil consumption. Okay, and this is the from 1996 to 2007. This is oil production for Saudi Arabia and for these number of years. And we're going to run the exponential smoothing using fit. Okay, and here we can also have like production month of 1, 2, 3, 4, 5, and the demand as 290, 260, and so on and so forth. And we put it into a data frame. So as you can see, the data frame itself has two columns, one called a month and the other one called demand. Okay, and we have several, and we can see the shape. Actually, the first column, which is column 0 for this data frame, has 12 number. So we're going to start using this initially as part of a exercise. We can do a so-called simple moving average for these three data. Okay, let's take a look. And we're using a for loop. Okay, for loop. Okay, in all the way from from range from 0 to shape of a 0, which is a shape of a 0 column, which is giving me 12 minus 2. So I only run this loop for 10 times. Okay, actually, I want to calculate a new column called SMA, so a simple moving average of 3 periods. So I basically adding 3 periods together, divided by 3, and so on and so forth. So after I run this loop, okay, and you probably see the data frame looks like these are the demand for each one of the month. Then the simple moving average of 3 period will be the first 2 period would not have, because we start with the loop of on the third period, okay, and then all the way to the period 12. So this is a simple moving average you learn from PPIC already. But we can do similar things. We can see the result first adding a empty column called SMA3 instead of SMA underscore 3. Okay. And okay, we're using the oil data right now. The oil data is from 1996 all the way to 2007. And it is indexed by the day, yearly, which is on the December 31st, at the year end, the production or demand. And then first we're going to add those. We're going to see how the index from this. There's no index. So we can do the similar calculation for the oil data instead of production data. Okay, let's take a look. So similarly, we can do it for oil production and Saudi Arabia things. But using pandas rolling function, we can also using the rolling function in panda data frame to easily calculate simple moving average. For example, I'm going to create 2 more columns called panda SMA3 and panda SMA4, representing the 3 period or 4th period moving average. So we're going to using the column 0 as a demand, and all the rows but column 0. I'm using rolling with a window of 3, and I take a mean of those 3 windows. So it's kind of convoluted. From 1, 2, 3, period 1, 2, 3, we get a mean. Period 2, 3, 4, we get another average. Period 3, 4, 5, and then we'll get it. So this is a concept of simple moving average. It's in panda data frame the function called rolling. Okay. We can also using an expanding function to calculate the cumulative moving average. The cumulative moving average is, let me execute this first. The cumulative moving average is also concept is simple. Is in the first part we're going to use the first few periods. For example, here we have period 4 window equals to 4 or period equals to 4. So we take the first 4 demands or production, and we calculate our average and use for the forecast for the 4th period. okay, and so on and so forth. But next one, I'm going to use 1, 2, 3, 4, 5, first 5 period as the moving average for the next period. And I don't recall, you probably didn't discuss this in class for PPIC class, but this is fairly commonly used in stock prices, commodity prices, and using this moving average starting from the very beginning of your data. And this gives you much more smoother estimation, and so you always keep the distance in the past distance past information into your average. Okay, and we'll talk about later on how we using exponential smoothing to weight the data from the distance past or the data from the most recent thing. But here we just calculate. You can using expanding function right here, and you just tell them the minima equals to 4 and calculate the average or mean. So you see that the cumulative moving average, the first 3 period has no estimation, but you have starting from the 4th period, 5th period, and so on, you will have starting getting forecasts. Very similar to the simple moving average. The simple moving average is like a rolling, a convolute type of thing, but it's next we can execute this, and we're gonna plot this result for each one of those. The blue line represents the data itself, and the orange line represents the 3 years moving average, and the the green line represents the 4 month, and then the cumulated moving average on this. So it is fairly obvious. The cumulative moving average give you the most smooth or estimation or forecast. The cumulative moving average we can use for, now we're going to try it on the air quality data from, and reading the data from our canvas, and talk about columns, list all the column they have. I'm going to drop the last two, column 15 and 16. Other data don't have a name. I'm not going to include it in my analysis. And this is actually the data set you see. The day, actually, what we have, and the time, and different type of a toxin in the air, and how heavy they have. So these are the air quality. And you also notice at the very end, they have a 9,470 record. But at the end, there are some extra empty rows in this data set. So we need to clean them out as well. So processing an essential step. So here we see that. Look at this data frame. Is NA asking for if this is how many rows we have, and we sum them together and present. So is NA means is no data. Okay, so here we see in this data set, out of 9,470 record data, and we have 114 rows. We don't have any data, so we don't have any data for the day, time, and all these toxin in the air. So we probably want to delete or remove those empty rows. Sorry. So Panda data frame has a function called drop NA. So I'm asking the Panda to drop those rows without any information. In place equals to true. I want to execute it within this data frame already. So in place equal to true, it will actually execute the command. If you don't have this in place equal to true, and then it will just show you which frame will gonna be the result, but not actually execute. It's basically just display the result. So let's do this. Execute some of those. Look at the data frame. So we have 114 rows without any data, and then we're going to drop those. So now you can see there's no column, no rows actually have non-value. Okay, and then we're going to just taking the second to the last column called temperature. Okay, this is the weekend using as a temperature. You see the temperature. Actually, you can see second to the last, the T columns right here is the temperature. Okay. So now we're going to using the Panda to expand method, doing cumulative moving average on using period 4 to forecast the quality. I'm just going to show you the first 10 because you're using windows of 4. So the first 3, you're not going to have any value, any number, and the rest of them will be the cumulative moving average throughout. Okay. Next is a little bit tedious because the daytime information we have in the data frame, and just take a look. The day information and the time information, first we're going to combine them into one column, okay, into one column. Then I'm going to make this as an index for the entire table. How do we do that? Okay, first we're going to import daytime library and define a new column called daytime. Define a new column called daytime. Zoom in this a little bit. Define this. Sorry. Define these new column called daytime by this combination of the original column called day, adding a space in between, and then using the column time to combine them together. And also, I'm using a so-called pandas daytime lambda function to converting the string into a daytime format. So here, using the daytime column, applying the lambda function, using the daytime string to port it to converting to regular time. And the format is day, month, year, hour, minute, and second. And all this format follow a C convention, and we have given you a tab to look at the daytime. Okay, so time series. So here we execute this. Actually, we convert it into a daytime. Then we're going to using the daytime column as an index for the data frame. Okay, just set index dft temperature dot index equals to the column of daytime frame. And then we can plot it, and you can see the blue line is the original data, and the orange line over here represents the forced order or 4-period cumulative moving average throughout. Okay. Next, we're going to start talking about this. Next, we're going to talk about exponential moving average. Exponential moving average is also a method. You probably haven't talked about this, and in PPIC is commonly used also on stock and index type of prediction or forecast. So we load this library called stats models. So it's a statistic modeling library. Okay. Time series analysis is TSA, and API is application interface. We're going to import 3 different ones. First is exponential smoothing. Second is simple exponential smoothing. And the third is the host method and the host Winters method. That means it is that usually we refer as a double exponential smoothing with a trend. Okay. So I'm going to reading this. Okay. I'm going to create a new column called EMA, exponential moving average, using the temperature, okay, for row column 0, all the rows but column 0. Calling this function called EWM. Span is 40. Don't do any adjustment and just calculate means. We can see the exponential smoothing, how they look. So this is exponential moving average. You can calculate, call this function, with a 40-day period as this exponential moving average. And then we can plot it. Again, the blue line represents the original data, and the orange line represents the 4-period accumulated moving average. But you can see that the exponential moving average is the green line actually track the up and downs of the temperature quite nicely, especially these drop, and they can actually represent that in the model. And the trend of the zigzag data, it capture the trend, uptrend and downtrend. So exponential moving average is an excellent tool for like stock prices and volatility, or volatile stock or asset, and very sensitive at tracking the uptrend and downtrend in the investment sector. Okay, so we can calculate the simple moving average and compare it with the exponential moving average. Let's take a look. Here we have 4 different type of simple exponential smoothing. One is using heuristics and using different so-called smoothing level. Okay. And basically, we're using alpha value, which is how much weight I'm going to give it to the most recent data. If the last weight, which means I will incline to have, if alpha equals to 0.2, I will incline to give 20% of the weight for the most recent data and give 80% to the historical data in the distance past. If alpha equals to 0.6, and that means I'm giving the most current data and 60% of the way. So basically, how you weighted the most recent data as opposed to the distance past data. And there is uh, the third one actually just using regular function and then telling the model to figure it out what is the most accurate alpha value by itself. Okay, so here we have a 0.2, 0.4, 0.6, and whatever the model can find the best alpha for those. We're going to plot it out, and you can see the black ones actually. The black one is the alpha equals to 0.2, and blue one is optimal alpha, and the green one is alpha equals to 0.6 actually. So we can see that, and the red is the original data. All right. Next, we're going to talk about host method. And host method has like we said, it has simple exponential smoothing, but with the trend data. So here we're going to have a two parameter. One is alpha, one is beta. Beta is first we're going to estimate the most current data or the distance past data. The beta is the estimation for the trend. So how much information we're going to give into the trend type of, or we call it with uptrend or downtrend information from the most current data or the distance past data. Here we're using three different type of model and three different type of forecasts. So first we build a model, okay, using smoothing vector of a smoothing level of 0.8, the smoothing trend as a 0.2, so 20%. Not going to using any optimization. So this is a host method with a linear trend, okay. And the second, we're going to use the similar things, but with the so-called exponential trend. Okay, exponential trend. And the third one, I'm going to using a so-called damped trend. See if they have any kinds of up and down situation. We're going to catch that trend. So these are the three different possible model. First is a very simple, straightforward, just linear trend. Second is any of the trend we detect is in the exponential curve, or the trend is in the damp version, which is up and down cycling. So we're going to execute, and then we're going to do forecast for 5 period afterward, because we don't have no historical data, and we're just going to forecast for the next 5 period. And I'm going to plot it out, show it to you. So you can tell this here we have quite a bit of a trending data using air quality data we define in the beginning of the notebook. It's kind of trendy. You see that it's uptrend, and so we have a linear trend. Actually, the linear trend and the three colors, the red, blue, and green, represent the three different trend from the model from three different forecast model. Okay, like I said. Okay, I think the green represents the damped model. The blue represents the exponential, and the red represent the exponential, and the blue represent the linear trend. So we have three different type of forecasts.